Hello, I'm Mr. Precella, and today we're going to be discussing more about sets here in Math 1332. Hopefully you've already had a chance to read through the textbook about sets and to listen to Rebecca's video that comes with Pearson products. And now I'm going to start working through these homework problems. It says, indicate whether the set is true or false, and it has set containing DGJK equals the set containing JKGD. True or false? Well, equal sets have the same elements, but the order could be different. But not necessarily the same order, I'll say, but the order could be different. So, same elements, but maybe different order, maybe not. Let's see, on this one, they're the same elements. D, G, J, K, the order's different, but still, they are equal. Now, number 2 is a little tricky one. The empty set and the set containing the empty set. If you think of the empty set as an empty bag, one empty shopping bag is not the same thing as a shopping bag that has an empty shopping bag in it. Those are not the same thing. These are not equal. This thing right here is the set containing the empty set. It's not the same thing as just the empty set. For the same reason, one empty shopping bag is not the same thing as one empty shopping bag that's holding that has an empty shopping bag inside it. Okay? So these are not equal. The empty set and the set containing the empty set are not equal. Now, do you remember what this little notation means here? We have two types of subset notation. This means subset. It's sort of like less than or equal. Because of this little mark here, they could be equal. If it has, let's see, if it doesn't have that little mark there, then that's proper subset. They cannot be equal. Let me go ahead and state a formal definition here. A is a subset of B means every element of A is in B, and A could equal B. So it's possible they're equal sets. Maybe not. Now for proper subset, A is a proper subset means every element of A is in B, but A cannot equal B. Okay? So that means that A is smaller than B. There's more stuff in B than A. It can't possibly be equal. Now, if it's just a plain subset, then okay. So let's look at number 3 here. It says, decide if the given statement is true or false. If it's false, give the reason. Tugboat, yacht. Okay, the set containing those. Is it a proper subset of these? So are tugboat and yacht both over here? Yes. But they're not equal, are they? Okay? Therefore, that's a definition of a proper subset. A is a subset of B. Everything in here is in here, but they're not equal. So this statement is true. Can y'all see that? On to number 4. Decide, let me bring this down. Decide whether the following statement is true or false. We have a set of a set containing X such that X is a letter in the word lazy. Let's go ahead and list those out. It would just be L-A-Z-Y. Is that a subset? Notice not proper, just subset of the set of all Y such that Y is a letter in the word lazier? Well, let's list those out. L-A-Z-I-E-R. Is everything here also in here? Well, no. Which letter here isn't over here? The letter Y. So this statement is false. There's 2 statements that say false, but which one is it true? This statement is false because not every element in the second set? No. This statement is false because not every element of the first set is an element of the second set. This Y is in the first set, and it's not in the second set. Now, the next one. It says, decide whether the statement is true or false. And it says the empty set is a subset of the set containing the numbers 4, 28, and 80. Well, did y'all get this from your reading or from Rebecca's video? The empty set is a subset of every set. That's right. Did y'all hear that? So is this statement true? Yes. The empty set is a subset of every set. Now, number 6. Oh, we're just flying through these. Are there any questions? We defined equal sets. We said 2 sets are equal if they have the same elements, not necessarily in the same order, but it has to have the exact same elements. Now, what about equivalent? Number 6. Determine whether the following pairs of sets are equivalent. Justify your answer. Well, did y'all get this from your reading? A and B are equivalent if the number of elements in A is equal to the number of elements in B. Equivalent means the same number of elements. So don't have to be the same elements, just the same number of elements. So let's see, how many elements do we have here? 1, 2, 3, 4, 5. There are 5 here. Are the 5 over here? Let's count. 1, 2, 3, 4, 5. Yeah. So these things are equivalent. So it's either answer A or B. Which one is it? A says yes, both sets are subsets of larger elements. B says yes, both sets have the same number of elements. Are the sets equivalent? Yes, because both sets have the same number of elements. I read the cardinality is equal. Oh yes, the cardinality is another way of saying the number of elements in a set. Okay? Cardinality means number of elements in the set. We could say there are 5 elements in this set, or we could say the cardinality of this set is 5. Okay. Any questions? Now, let's see, number 7. Let's see. Determine whether the following pair of sets is equivalent. Justify your answer. Remember, equivalent elements have, if we want to be fancy, we'll say, or more formal, the cardinalities are the same. Informally, we'd say just the same number of elements. So let's see. This set says the set of all x such that x is a letter in the word scab. So how many different letters are there? 1, 2, 3, 4. You wouldn't count the S twice. So there's 4 letters. This set looks like this. S, C, A, B. There are 4 elements in there. This set over here, set of all x such that x is in the letter in the word pen, P, E, and N. There's only 3 letters here. So are these sets equivalent? Well, no, because they have a different number of elements. So C, those sets are not equal because, equivalent. Sorry. Well, they're sure not equal. 4 and 3 aren't equal. Therefore, the sets are not equivalent. Okay. So, here comes one of those tricky ones about the empty set. The empty set has no item in it. Nothing's in it. Here, what's between these set braces? Well, there's a symbol for the empty set. The empty set and the set containing the empty set, they're not equal and they're not equivalent. Because here, if you think of it, the empty set as a shopping bag with no groceries in it. This would be the shopping bag with no groceries in it. Over here, this would be the shopping bag that has another empty shopping bag within it. Not the same thing. Not the same number of elements. Not equivalent. Number 9. Okay, now this one's going to require that you know a little bit about leap years and how many days are in a year. Determine whether the following pair of sets is equivalent. Justify your answers. The set of all x such that x is a day in the year 2012, and the set of all x such that x is a day in the year 2010. The multiple of 4 years are leap years when we have the February 29th. So for 2012, there were 366 days in that year. 2010 was not a leap year. There were only 365 days. Now, 2012 is a leap year. 2016, 2020, 2024. The multiple of 4s are the leap years. So are these sets equivalent? Well, no. One has 366 days and one has 365 days. So no, the 2 sets have a different number of elements. Oh wow, now let's look at these 2 problems. There's a lot of writing here. Use the table to answer the question. Consider the set V, GPA below 2.0. Which set is equal to V? Well, let's see. Here's the GPA columns. The people with the GPA below 2.0 would be Brenda, Gina, and Elston. So which one is that? Doesn't necessarily have to be in this order. Is it B?
Yes.
Okay. Now, 11 is something like similar. It says, okay, Use the table to answer this question. Consider the set V GPA below 360. So I'm going to go ahead and, 3.0, 360. 3.0. Let's see. Here are the GPAs below 3.0. So here's the set V. Choose the set equivalent to V, but not equal to V. So we want to choose by equivalent, it should have the same number of elements. So we want to choose a set that has 3 elements, but not equal to V. So we don't want to choose Brenda, Elston, Carmen. Is that listed there? Brenda, Elston, that's not the one. Okay? So we want something with 3 elements, 3 names, but not equal to V. C? Is that what I'm hearing? This one has 3 elements, but it doesn't have, but it's not equal to Brenda, Elston, Carmen. Okay? So hopefully you're staying caught up with your assignments. If we move at the pace I've set up there, then you should be able to get everything done without having to cram too much around the tests and the quizzes. So this was section 2.2 involving the language of sets. Next we'll be looking at things like union, intersection, operations on sets. So thank you for listening, and enjoy working on these sets.